All right, guys, this is going to be the last kind of reminder and bringing together of the idea of isotopes, and then we're going to add in the last detail, which is ions, which you've started playing around with last week, but we haven't really done any actual work with. So before we start, I'm going to remind you that in a regular, everyday, boring atom, we will assume that the number of protons, neutrons, and electrons are all the same. That is the assumption according to the state of Virginia. So in a regular atom, all of these things are the same. You will know how many of these there are because you will look on your periodic table for the atomic number, which will tell you the number of protons. That's where we're going to start. Now, last week and the week before, we spent a lot of time talking about isotopes, and there still seems to be a lot of folks not making the connection between what these words mean and basic vocab. So let's make sure we're clear here. When we have isotopes, what has happened is that the number of neutrons in the atom have been changed in some way. The only way that you know that they have been changed is that there will be a mass number provided to you. And just like we talked about before, the mass number is not on the periodic table. A lot of folks are still pulling numbers off the periodic table for this, and that's not on the periodic table. The mass number is the sum of the protons plus the neutrons. It is always a whole number. You will know that you have an isotope because it has special ways of writing it. We have isotopic symbol, which is what we mostly used last week. So that would be when it's written like this, right? Or sometimes they'll put another number down on the bottom like this, okay? In these cases, both times that top number is the mass number. It is the sum of the protons and the neutrons. If they put a number on the bottom, or if they don't, it does not matter because I can use my periodic table to look up carbon and see whether it's provided or not that carbon has 6 protons, and I can do the math to figure out how they got that 14. And I can see that this is an isotope with 8 neutrons. Okay. The other way that this is written is hyphen notation. This is a hyphen. It is not a negative sign. Okay, so this is the review from last week. Now what we're going to do is we're going to add one more detail to this, and we're going to talk for just a little bit about ions. And we haven't done any ion calculations yet, so this will be new, and we'll put this on a different slide for you. So up here at the top, I'm going to write it again, that an atom has the same number of protons, neutrons, and electrons. Neutrons have no charge, so that's why they have to give us mass numbers. Protons and electrons have opposite charges. This makes a regular atom neutral because it's going to have the same number of positives and negatives. But sometimes, sometimes atoms have charges. The only way to get a charge on an atom is to change the number of electrons. If you change the number of electrons, you have an ion. So this is an atom where the electrons have changed. Okay. Because remember, we don't ever change the protons because that is what identifies the atom. So ions are atoms where electrons have changed. Now, just like isotopes had fancy ways of writing them so we would know that had happened, the same thing is true here. If we have an ion, we're going to know that we have an ion because the positives and negatives are no longer going to cancel each other out, and we're going to see the element written with a charge. It's going to be really obvious. So we might see something like oxygen -2, or maybe we'll see potassium with a +1, or calcium with a +2, right? They're always written on the right side. These are the charges. This is your big red flag that means electrons have been changed. So that's how you know that you're dealing with an ion. There are only two types. They are positive or negative because either you are adding electrons or you are subtracting electrons. So let's make sure we're clear on which one is which. So over here I have oxygen -2. Now if I look on my periodic table, I will see that oxygen has 8 protons. That means it has 8 pluses, right? 8 plus charges for the protons. This oxygen has a -2 charge. That means it has more than 8 positives, right? It's got to have more electrons so that they no longer cancel out. So it doesn't have 8 electrons. That would make it neutral. It has to have extras. It has 10 electrons. So now I have +8 and -10 for a difference of -2, and that is where the -2 comes from. So when you have something that has a negative charge on it, it means that additional negatives have been added. Okay. These are extras, extra electrons. Now these two are both positive. I can walk through it in the same way though. I can look at potassium, which is 19. So that means that it has 19 protons. And if it were neutral, it would have 19 electrons, so they would cancel out. But here they don't cancel out. There's one more positive than there is negative. So one more positive than negative. So that means that what I really have are 18 electrons because I'm not allowed to change the number of protons. Same thing for calcium here, right? If I look it up, calcium has 20 protons. If it were neutral, it would have 20 electrons, so they would cancel out, but not this one. This one has 2 more positives than negatives. I'm not allowed to change the positives. That means I change the negatives. So when an atom has a charge, it is an ion. It will be obvious because it will literally be written right there on it. Okay. The generic terms here that you have to have before we get to the last slide, you have to know that an atom has everything the same, that an isotope has neutrons changed, and you'll be seeing a mass number of some sort, and that an ion has the electrons changed, and that it will have a charge of some sort. So now we're going to put all 3 of these together on the last slide. Okay, here we go. If I have an atom, and I'm going to do a consistent example throughout this whole slide. If I have an atom of nitrogen, I can look on the periodic table and I can see that nitrogen has 7 protons. So it will also have 7 electrons because it will be neutral, and it will have 7 neutrons because that's what happens in a regular atom. If I change something though, if I change the neutrons, I will now have an isotope of nitrogen, and I'm going to have to be given extra information. So here for my isotope of nitrogen, I have N15. So when I look on my periodic table, I still have 7 protons. I still have 7 electrons because there's no charge, but now I have a mass number of 15. So I have to figure out 7 plus what equals 15. So that means now I have 8 neutrons. If I change the number of electrons, I will now have an ion of nitrogen. So for my ion of nitrogen, Nitrogen actually has a -3 charge when it is an ion. I look on the periodic table, it is still always 7 protons. There is no unusual mass number here, so I assume that it also has 7 neutrons. There's no reason to think that it doesn't. But here I see it's got a -3 charge. That means it has 3 extra electrons. So it will have 10 electrons. We should be able to quickly move or easily move between the numbers of protons, neutrons, and electrons for atoms, isotopes, and ions. You may also see subcategories of ions. They're just vocabulary words here. If an ion has a positive charge, it's called a cation. Like this one has a negative charge, it is called an anion, but I spelled that wrong because I was talking. Anion. Okay, so if it has a negative charge, it's an anion. If it's a positive charge, it's a cation, is how you say those. Okay. So you can have atoms, you can have isotopes, and you can have ions. And then the last thing is you can have all three. I can have something like phosphorus, and it can have a mass number like 32, and it can also have a charge. So it is an isotope and an ion all together. I need to be able to find the subatomic particles for all of these. These are like little puzzles. I should be very, very clear that protons are simply the number from the periodic table. It is 15. That is going to be set in stone. I need to figure out the neutrons. Well, that's what the mass number is to help me with. 32 minus 15 will give me the number of neutrons. So I think that makes that 17. Right? And then this is 3 extra electrons, 3 more electrons than protons. So it has 18. This is not difficult math, but it is a little tedious if you're not sure on what these different numbers and symbols stand for. Okay. This is a topic that is taught for years and years in science, starting all the way back in 7th and 8th grade, and it's not going to go away, so we want to make sure that we're really good at this. You will have some proton, neutron, and electron charts to fill out. This is how you do it. So if you have not been taking notes while you watch this, please go back, watch it again, and do some notes, because those notes and practice are how you are going to be able to do these problems consistently and confidently, because practice is what makes things permanent. If you only look at it one time, it will not be permanent and you will be frustrated, and nobody wants that.